Alright, this is Unit 3 Polynomials. We're working on Day 2, Example 2. So it asks us to list the factors, roots, and multiplicities of each function sketched below. Then write a possible equation. So let's take a look at our graph. Remember, roots are just where they're crossing or hitting the x-axis. So it's whenever it's touching the x-axis. Those are my roots. So I've got one at 1, and then my other one is at 3. So my two roots here are x equals 3 and x equals 1. To turn these into factors, factors are the things you multiply together to get another number. We have to get the 3 over on the other side of the equal sign. So if I want to make this equal to 0, I'd have to subtract 3 on both sides. So one of my factors would be x minus 3. And then same with this one, x equals 1. To get it on the other side, I would subtract 1. So it would be x minus 1. Those are my two factors for this equation, or this graph. Multiplicity. Multiplicity is what's happening to the graph at the root. So if we look at these roots are bouncing or hitting the x-intercepts or hitting the x-axis when they get to those x-intercepts. So they're bouncing. So think back to our parent functions. Remember, for y equals x, our graph was a linear. For y equals x squared, our graph was a quadratic. So that was the U shape. And for y equals x to the third, a cubic, our graph was that snake or swivel at the root. So if we look at these roots, you can see at the root, if we focus only on the root, what shape is that? That's a U shape. It's bouncing, so it has the same degree as, or excuse me, the same multiplicity as this one. So it means it's a multiplicity of 2. So for root 1, the multiplicity is 2. And my other root at 3 has the same multiplicity because it's bouncing off of the x-axis. So that multiplicity is also 2. The end behavior for these graphs, we look at the right-hand side. So as x approaches infinity, f of x approaches negative infinity because it's going to the negative values of y. So the possible equation is you can write f of x equals, using your factors, x minus 3 times x minus 1. Now here's where the multiplicities come into play. At each root, the multiplicity we said was 2. That's going to be our exponent for our factors. Because we said the multiplicity was 2, it was bouncing off, so we know that it should have an exponent of 2 based on the shape of the graph. So let's try the next one. Same idea, identify the roots. So here my roots are negative 3, negative 1, and 4. These are also known as the x-intercepts. So I'll write that down on the side. So if you see either word, you're comfortable seeing either. X-intercepts are roots. So here we had negative 3, negative 1, and 4. So the factors would be x plus 3, x plus 1, and x minus 4. Taking a look at the graph, at negative 3, the graph, if I just focus on that negative 3, that is a bounce. So it has the multiplicity of 2 because it looks like my quadratic. At negative 1, we focus only on a negative 1. It's going through, straight through, so we call that a multiplicity of 1 because it looks like a linear. And at 4, you can see it kind of swivel there, where it comes up and then flattens and swivels again. So we're going to say that this is a multiplicity of 3. For this one's end behavior, as x approaches infinity, f of x approaches positive infinity because it's going into the positive values. So a possible equation would be f of x equals x plus 3 squared, because my multiplicity is telling me that's the exponent, times x plus 1 to the first times x minus 4 to the third. Sometimes you will not see the 1 written. It's really just up. Normally it's not written. So those are your examples for multiplicity, x-intercepts or roots, factors, end behavior, and possible equations.